The Eurofighter Typhoon is the world's most powerful and reliable swing-roll combat aircraft. Eurofighter Typhoon delivers an enviable level of flexibility and efficiency. Only Eurofighter Typhoon possesses both adequate weapon availability, up to 6 bombs whilst also carrying 6 missiles, a cannon and a targeting pod, and sufficient processing power to simultaneously support missile in-flight updates and bomb in-flight targeting. True swing-roll capability. The aircraft is designed to be upgraded and extended in order to provide decades of effective use. Combining a proven, agile airframe built from stealth materials with the latest sensor, control and weapons systems delivers optimum combat capability, both beyond visual range (BVR) and in close combat. The weapons systems, navigation technologies and control infrastructure are all designed to be upgraded, to continue to enhance the overall performance of the aircraft. The airframe. The aircraft is built with advanced composite materials to deliver a low radar profile and strong airframe. Only 15% of the aircraft's surface is metal, delivering stealth operation and protection from radar-based systems. Pilots were included in the design from the earliest stages to develop a deliberately unstable airframe that can still be flown effectively.
This delivers both superior maneuverability at subsonic speeds and efficient supersonic capability to support the widest range of combat scenarios.
Eurofighter Typhoon specifications. Max speed Mach 2.0. Thrust 90 kN from each of the 2 Eurojet EJ200 turbofans. Length 15.96 meters. Max altitude above 55,000 feet.
Wingspan 10.95 meters.
The materials. Strong, lightweight composite materials were key to the design of Eurofighter Typhoon to give it deliberate instability. Using them means the weight of the airframe is 30% less than for traditional materials, boosting range and performance as well as reducing the radar signature. Carbon fiber composites, aluminium, lithium, titanium, glass, reinforced plastic, aluminium casting. General materials. Carbon fiber composites 70%. Metals 15%. Glass reinforced plastics, GRP 12%. Other materials 3%. The twin EUROJET engines. Developing cutting-edge engine technology has been a key part of the Eurofighter Typhoon project from the start. 4 global companies have jointly developed the high-performance EJ200 power plants that each provide 90 kN of thrust from a small lightweight engine with high strength and high temperature capability. The 2-spool design with single-stage turbines drives the 3-stage fan and 5-stage HP compressor with annular combustion with vaporizing burners. This allows Eurofighter Typhoon to cruise at supersonic speeds without the use of reheat for extended periods. The engines deliver 1,000 flying hours without needing unscheduled maintenance through the use of advanced integrated health monitoring for class-leading reliability, maintainability and through-life cost. Sensors. Class-leading sensors give the pilot the unparalleled situational awareness, seamlessly integrating data and updating the battle space picture for actionable intelligence. The fusion information superiority allows the pilot to dominate the battlespace. Pirate infrared sensor. The Pirate sensor is the first in the world design derived from the weapon system specification and an ideal supplement to radar and the DAS defensive aid sub-system. With its passive sensors, it allows to simultaneously detect and track multiple and maneuvering targets.
Radar.
The Captor M mechanically scanned radar is a best-in-class radar, offering an extensive suite of modes to meet customers' operational requirements, as well as providing a very competitive field of regard. The Captor E electronically scanned radar is the future primary sensor on Eurofighter Typhoon and has a full suite of air-to-air and air-to-surface modes. The capacious aperture of the Eurofighter Typhoon allows the installation of Captor E's optimized and repositionable array, whose field of regard is some 50% wider than traditional fixed-plate systems. This wide field of regard offers significant benefits in both air-to-air and air-to-surface engagements, and given the large power and aperture available, provides the pilot with much enhanced angular coverage compared to fixed-plate systems. Air-to-air features. Search modes: range while search (RWS), velocity search (VS), and multiple target track while scan (TWS), lock follow mode, which are tailored for long-range tracking and short-range tracking for use in visual identification or gun attacks. Air combat acquisition modes, allowing a choice of boresight, vertical scan, HUD field of view, or slaved acquisition. Air-to-surface features. Search modes: ground map, high-resolution map, ground moving target identification, and sea surface search and track while scan. Track modes: fixed target track and moving target track.
Air-to-surface ranging.
The cockpit. Throughout the design process of the Eurofighter Typhoon, the needs of the single-seat pilot have been paramount. This has meant high levels of attention have been paid to the control and information interfaces throughout the unique glass cockpit, from the head-up, head-down and head-out systems to all-round vision. High workload situations were analyzed to establish information priorities and automate tasks. The advanced cockpit design and layout is based on an extensive series of formal assessments in a rapid prototype facility, undertaken by operational pilots from air forces flying the Eurofighter Typhoon. Using and upgrading the advanced digital technology not only enhances operation and survivability, but also simplifies aircraft maintenance. Other features such as direct voice input (DVI) and hands-on throttle and stick (HOTAS) control functions have been implemented on the Eurofighter Typhoon to drastically reduce the pilot's workload.
Voice plus throttle and stick (VTAS) enables single-pilot operations even in the most demanding air-to-air, air-to-surface and swing-roll missions.
Head-up display (HUD). The Eurofighter Typhoon's wide-angle head-up display (HUD) provides the pilot with stable, accurate, high-integrity, low-latency eyes-out guidance in a compact package. The HUD offers high performance that is compatible with night vision and laser protection goggles. Head-down display systems (MHDD). 3 full-color multifunction head-down displays (MHDD) are used for the overall tactical situation, presenting the attack situation, attack formats, map displays and air traffic procedures, in addition to system status and checklists. Helmet-mounted symbology system (HMSS). Eurofighter Typhoon utilizes a unique helmet-mounted symbology system (HMSS) alongside 6 other pilot display surfaces. HMSS provides flight reference and weapon data aiming through the visor. It is fully compatible with night vision aids using light intensification and forward-looking infrared (FLIR) imagery. It therefore offers pilots a significant competitive advantage. The helmet is composed of an outer helmet, inner helmet, optics blast, display visor, oxygen mask, night vision enhancement camera and head position tracking system. Navigation sensors. The latest sensor technology supports automated and inherently covert operation down to 100 featuring. Eurofighter Typhoon's navigation aids include a global positioning system (GPS) for full digital interface with individual satellite tracking channels and improved anti-jam capabilities. The package also includes an inertial navigation system with GPS. In addition, the navigation system features integrated lateral cueing and vertical commands, ensuring safe maneuver with 3D situational awareness. Flight control. The Flight Control System (FCS) is a full authority and quadruplex digital system which allows carefree handling and maneuvering in all situations. Its intuitive operation is designed to enable the pilot to concentrate on the tactical tasks and to fly the aircraft head-up in combination with the HOTAS hand-on throttle and stick concept applied to cockpit design. Automated emergency recovery features have also been embodied in the system design to ensure maximum safety of operation. Multifunctional Information Distribution System (MIDS). MIDS is an advanced data link, a multifunctional digital information distribution systems that allows the aircraft to securely exchange real-time data between a wide variety of users, including Air Force and, where appropriate, land and naval forces. It is high-speed, high-capacity, secure and jam-resistant while able to share and receive information from other users in their network. Defensive Aid Subsystem (DAS). The DAS suite is comprised of wingtip electronic support measures and electronic countermeasures pods, ESM, ECM, missile warners, chaff and flare dispenser and an optional laser warner. Upgrades in computing power will support continuous protection from future threats, enhancing Eurofighter Typhoon's survivability and greatly increase overall mission effectiveness.
Weapons.
As well as short-range air-to-air missiles, SRAAMs, and the 27mm Mauser cannon, the Eurofighter Typhoon carries the latest beyond visual range (BVR) air-to-air missile technology, such as the Meteor Advanced Long-Range Missile. This will provide the largest no-escape zone of any air-to-air weapon, resulting in a long stand-off range and high probability of interception to ensure air superiority and pilot survivability.
Guidance is provided by an active radar seeker with mid-course updates via data link.
The Laser Designator Pod (LDP) enables precise location of targets and guidance of air-to-surface weapons. Eurofighter Typhoon has also been upgraded with Paveway IV and Brimstone to provide high levels of operational flexibility. The combat-proven dual-mode guidance system, coupled with height of burst and penetrating capability, enable the decision of target engagement to be made right up to the point of release. Eurofighter Typhoon will see the constant integration of new, smart weapons in accordance with the demands of current and future customers. Storm Shadow, Taurus, small-diameter bombs, and anti-shipping missiles are just some of the upgrades planned. Life Support Systems. The Life Support System and Aircrew Equipment Assembly (AEA) is unique to Eurofighter Typhoon and includes full-cover anti-G trousers (FCAGT), a chest counter-pressure garment (CCPG), and a liquid conditioning garment, as well as nuclear, biological, and chemical (NBC) protection.
The helmet incorporates the latest helmet-mounted symbology system (HMSS) and optical protection. For pilot comfort and optimum performance capability, Eurofighter Typhoon uses computer-controlled anti-G and breathing support technology.
Ejection seat. The Mk-16A ejection seat on the Eurofighter Typhoon is 30% lighter than equivalent ejection seats. This is achieved by combining the twin ejection gun outer cylinder tubes as both the propulsion system and the seat's primary structure. The narrow head box also contributes to Eurofighter Typhoon's excellent rear vision. The seat integrates an onboard oxygen generation system (OBOGS) and communication systems. The simplified combined harness allows unassisted strap-in, and the passive leg restraint system avoids the need for the pilot to wear restraining garters. A second-generation electronic sequencer is also incorporated. Reliability and maintainability are key elements of the design, with full access to in-cockpit components. Fuel system. Throughout the aircraft, flexible couplings connect the fuel pipework built into the three main fuselage sections and wings.
These provide a simple method to connect the fuel tanks, which all have fuel flow proportioners to maintain the center of gravity alongside relief valves to maintain air and fuel pressures. The intelligent computer-controlled fuel system ensures long range, flexibility and safety.